Okay, it is a distributed data processing system. So in the sense, the data which you are going to write is going to be distributed. So where the data is going to be distributed, Hadoop supports a concept called JBOD. It supports a concept called JBOD. What JBOD stands for? Just bunch of disks. Okay, it supports a concept called just a bunch of disks. That means what is the Hadoop nav? The data which you are going to process, which is available in the cluster, right, is available in a bunch of disks. And what we are going to do now, the data is going to distribute it to a bunch of disks. Now we configure the bunch of disks as some nodes. So it's something like we have a node 1, it's a data node 2, it's a data node 3, and the reference is written into the name node. Okay, now so whenever you are going to write the file, any file you are going to write, either you are writing through the scoop or you're using a flume or you're copying the files to the cluster, right? So whatever it may be, so how you are going to write the input data, that input data is going to be distributed. How it is going to be distributed? It is going to distribute as a small size of chunks. Okay, how it is going to be distributed? It is going to distribute as a small size of chunks. So we call these chunks as blocks. Okay, we call
Okay.
these chunks as a blocks. So every block will have the specific amount of size. Either it can be a 64 MB or it can be a 128 MB or it can be a 256 MB based upon your system configuration, based upon your processing capacity, based upon your input data size. You have to determine what will be the best block size suitable for your Hadoop cluster. Okay, so now either it can be 64 MB. So now what is the default block size? So you have a configuration file, that is sdfs-site.xml. If you open this sdfs-site.xml, here you will find a one property. The property name is dfs.block size. Okay, so what is the property name? dfs.block size means
Okay.
the block which you are going to write in the cluster will follow the default block size. So how much you specified here, each block is going to be created that much of size. Okay, means now whenever you are going to write the data into the cluster, that data is going to be converted into the small size of chunks, which we are calling it as a blocks, where each block size is a 128 MB. Now, so how much files, what is our file size here? We are going to write 1000 file size, correct? And what is the block
Okay.
size here? 128. Means how many blocks are going to be created?
8 blocks.
Right, so we are going to create 1000 divided by 128. So total 8 blocks are going to be created. So in this 8 blocks, so always first 7 blocks are the same size. Okay, and the last block is a different size. It's a rule. Okay, so means first 7 blocks filled with a 128 MB and the last block will be something less. So total 7 blocks are going to be created. Okay, and Hadoop supports a commodity hardware. Commodity hardware in the sense, so we can expect the failure of that particular data node goes down, right? At any time, each data node may goes down, but that doesn't make any effect to your job processing, right? Suppose maybe some data is available in this data node, right? If your this particular data node goes down, then so the same blocks are available in somewhere, means we are going to replicate the blocks. So if we have the replication of blocks are available, so means you're making the multiple copies of the blocks. Okay, so Hadoop supports a concept called replication, right? So what it will support, it supports a concept called replication. Means every block we are going to write is replicated some specific number of times. It's how many number of times now? So it's
3 times.
specified by the property dfs dot replication, right? In a sdfs-site.xml, we have the property is dfs dot replication. So if it is 4, then your replication factor is 4. If it is 2, your replication factor is 3. So the default right now we are using dfs dot replication is 3. Okay, now each block which we are going to write, which is created, is going to be replicated. So total how many blocks we are having? 8 blocks, right? That is block
Yes.
1 and block 2 up to total 8 blocks are going to be created, and each block replicated 3 times, right? Means we have a 3 block 1s are available, 3 block 2s are available, right? Like that we have the 3 block 8. So each block is going to be replicated 3 times. So total how many blocks created now? 24
8.
blocks,
Yes.
right? Now these blocks are placed into the cluster. How these blocks are placed? So it follows a policy, that is block placement replication policy. Okay, we have a rule, we'll see this rule later. So it follows block placement replication policy. According to this policy, these blocks are going to be distributed to the all the data nodes, right? Available data nodes means somewhere in data node 1 will have the block 1, again some data node will have the same block 1, right? Like that each block is going to be replicated into all the available data nodes. Are you clear with this now? Right? How the
Yes.
data, how we are going to write the blocks into the cluster. Right? Now these blocks are placed in the cluster. So now where these blocks are written, they are blocks are writing now. These blocks are going to be distributed to the data nodes, but not the name node. Okay, see now whenever you are going to write this sample, now this file is converted into the file size. Here it is 1000 MB, means this many number of blocks are going to be created. So now what happens? Now the name node contains only this information. Which information name node contains? The metadata. So the file name is a sample, the block size is 128 MB, replication is 3, date and time when it is created, and
Where it went to
right,
data node.
privileges, it will contain some privileges. Okay, owner name is Hadoop and a group name is Hadoop. So this particular line is written into the name node as a name node's metadata. Now the content of this file sample is the these 8 blocks. The content of the file sample is the 8 blocks. Now these blocks where the data is available, where the data is distributed, that blocks are equally written into the data nodes. Got it now? So when you run the job, now the job tracker will take the request from the client. Suppose here the job is you wrote something, select count of start from file name. Okay, so here you run a job. What is the job name? Select count start from sample. That means what it has to do now? It has to count all the right number of rows are the records from the table sample. But where we are having the data sample, the sample data internally available in a data nodes as the blocks, means the complete number of rows are available in block 1 to block 8, right? Not in only block 1, not in only block 2, right? So means you have to count all the rows in a all the blocks, then only you will get the complete total number of rows in a table. Got it now?
Yes.
Okay, so now so select count star from sample, right? So this is the job which we are going to write now. The advantage with the Hadoop is the job is going to be executed in the place where the data is available. Now what we are doing now, we are writing these blocks. So some blocks are written here. Okay, so some blocks are block 1 is available, something block 3 is available here, right? Some like this the blocks are going to be distributed. Now when you're running a job where the data is available, the data is available in this block. And who is executing the job? The task tracker, means the job is running in the place where the data is available. Got it? So why Hadoop is having this kind of architecture? Why Hadoop jobs are the faster? Because the jobs are executing in the place where the data is available. Generally, what we have to do in a three-tier architecture, so the data and the client both are connected to the server. So the data from the database will be available in the server, client connect to the server, and the data processing is going to be done in the server side, correct? But here in the Hadoop, so where the blocks are available, right, where the data is available, in the same place, we are having the task tracker who is going to run the job. Okay, so now the task tracker is going to execute the job. Clear now? So why Hadoop
Okay.
jobs are faster? Because we are running the job where the data is available. So now, so the job tracker take the request from the client, and it will get the reference in the name node. So what is the reference means? So where this information is available, the user which is looking is available in a which file. So that reference job tracker will get the from the name node, and it will assign the job to that particular task tracker, right? The job is going to assign to a task tracker. Now the task tracker will take the data from this block and it runs the job, right? So this is how your job is going to be processed,
Okay.
right? So this is in Hadoop before 2.0. Now here what happening, suppose if your name node goes down, right? In a Hadoop cluster, always name node is the single point of failure. If your data node goes down, what happens? Nothing is going to happen, because if this block one is goes down, but we are replicating the blocks 3 times, so where we have the same block one is available in this data node 3, right? So if your data node goes down, then we can run the job from this data node 3, right? So if your data node goes down, so nothing is going to be happen. So if your name node goes down, then uh, how you get the reference now, how we identify which file is available in which data node? No, we don't, it's not possible, and we don't get the what we call, we don't get the reference, right, where actually the data is available. We are not able to identify that. So it's think that if your name node goes down, the entire cluster is down. Okay, so
Okay.
so now here what we are doing, we are using a some alternate name node, right? It's not the backup of the name node. We call it as a secondary name node. So we are taking, right, a snapshot of the primary name node into the secondary name node. Okay, what is secondary name node? Secondary name node is not mandatory, and there is not much priority given to the secondary name node, right? So whatever the data which is written into the name node, so whenever the checkpoint occurs, the snapshot of the primary name node's metadata is going to be updated into the secondary name node. Okay, so we'll see this point later. Now we have a secondary name node, so this information's copy is written into the secondary name node. So here, this kind of environment so doesn't give you the complete high availability. Okay, so if your name node goes down, and so you have a copy of previous image file in secondary name node, so you have to get that fs image file into the name node, and then you should make up and run the cluster. So here the chance is, so we are unable to get all the data, right? Here is a chance we are going to lose the data, and it's not high available environment, right? So no 100% high availability, this one. Okay, did you understood what is high availability?
Yeah.
Right, because if your name node goes down, so your cluster is down for some time, and so if the checkpoint is not occurred, then we are going to lose the data too, right? So this is Hadoop before 2.0. Now in the Hadoop after 2.0, to make the cluster available, so always we talk about Hadoop, right? Hadoop before 2.0 and Hadoop after 2.0, right? Always when you're speaking with something related to Hadoop, so we always speak in the sense before 2.0 and after 2.0. So Hadoop before 2.0, it can be a map reduce, correct? So Hadoop
Yes.
after 2.0, what it is?
Yeah.
Yeah, right. So where the difference comes, now we are going to run the non-map reduce jobs too. So here it's not mandatory that you are going to write the map reduce. We can able to write a non-map reduce jobs in Hadoop after 2.0. So where the difference comes now, so in the Hadoop yard, so what we'll do now, see here, if you go through this diagram, see now, observe what the job tracker is doing. First, job tracker is taking the request from the client, and in the name node it is trying to get the reference from the name node. Then it is going to the data node, and it is assigning the job to the task tracker. So while the task tracker is executing the job tracker is waiting for the result from the task tracker. Once the job is completed, it has to get the output from the task tracker, and it has to display back to the user. One job tracker is going to do this many number of tasks, correct? So means once one job is going to be finished, remaining jobs are in a pipeline, in a queue. So right, so again here it is a little bit drawback, right, in this architecture. So what are the issues? We have two issues. One is we cannot able to process the multiple jobs simultaneously, and the second one is we are not giving the 100% high availability, right? So these are the main two drawbacks in this architecture. And so other one is we always able to run a map reduce job, right? So very difficult, and the debugging is difficult. You need to write heavy code. Okay, now so what we did in the Hadoop after 2.0, now we can have a name node like this, and we are going to configure one more name node. Okay, how many name nodes we are having? Two name nodes. Okay, and then one secondary name node. So in a Hadoop cluster, how many name nodes generally will have?
Three name nodes.
Right, no, we'll have only Hadoop before 2.0, it supports only one name
Two.
node. Right,
Okay.
in Hadoop 2.0 onwards, we can able to configure many number of name nodes. Right, we cannot say two nodes or three nodes. Right, so in Hadoop 2.0, this is a yard. So here we'll have the name node. Okay, and again here we are having a some, what we call it as a HA node,
Second.
not secondary
Okay.
name node. We call it as a high
HA.
availability node, HA node. Okay, and as usual, this is our regular secondary name node.
Edge node account అండి.
Yeah, yes, let me complete this. Okay, so we have an HA node and secondary name node. Now these are the data nodes. Okay, so now how many data nodes here we are having? Four data nodes, correct? So
Yes.
data nodes 1, data node 3, data node 4, data node 5, right? Something we are having the some data nodes here. Now, so in the Hadoop 2. Before 2.0, we have a job tracker where the job tracker has to process everything, right? So now
Yeah.
here, instead of the job tracker, not instead of the job tracker, apart from the job tracker, we'll have a resource manager. What we'll have? We'll have a
Okay.
resource manager. Okay, so no job tracker, we call it as a, we use a resource manager. So the resource manager is works as a resource manager plus application master. Means in the previous environment there is only one employee has to do both the jobs. Now we have recruited two employees. So where the difference now? In the previously one person has to do everything. Right now you have the new two persons are available. That means the jobs are going to be faster. Okay, so now
Okay.
here wait, I'll touch that point. So here we have a resource manager. So where resource manager configured as works as a resource manager as well as application master. And in the data nodes, instead of the task tracker, we'll have a node manager. What we'll have? We'll have a node manager. Okay, so this is Hadoop after 2.0. We call this as a yarn environment. What we call it as a yarn.
Yarn.
Yarn stands for yet another resource negotiator. Okay, yarn stands for yet another resource negotiator. Okay, now see, we have a, instead of the job tracker, now we have the resource manager and application master. Now resource manager will allocate the resources, and application master will monitor the monitor the application processing. Okay, so previously only job tracker has to do allocating the resources, as well as job processing can be done by the job tracker both, right? Means at one time we can able to process only one request, but here in the Hadoop 2.0, now whenever client issued a request, the client request is taken by the resource manager. Okay, then the resource manager will allocate the resources for this job. Okay, so whenever client entered some job, select count to start from the table name. Now resource manager will take the request from the client. Okay, after that it gets the reference from the name node. Then in the name node it will identify the uh, reference, right, in which data node this particular file is available. So it will goes to that particular data node, and in the data node will it will create a container. What it will do, it will create a some container, right, for this to job run the job. Now the job runs on this container, and the job will be given assigned to the node manager. Now this application master is going to process the job, can able to identify, can able to monitor the request. Right, now resource manager job is completed. Now this job processing, allocating, monitoring the job, and if the job goes down, right, now all these things are done by the application master. So while application master is working with this one, now resource manager can able to take another request. Okay, so application master works with the job one. Now resource manager can able to take a second request from the client. So means in this way we can able to process multiple jobs simultaneously. That it enough? So because in the
Yeah.
previously I am the only one, right, I has to do everything. Now what they did, now we both are working, you and me. So now we distribute the work, right? So I'll take the job from the client, I'll show you the resources, I'll show you the place, and please you work in this place, right? I'll show you that one and I'll go. Then you will come and you have to monitor how is working the job, how the job is working, right? So what are the other resources, the other parameters required, the job processing is monitored by you. So meanwhile you working, so what I'll do now, I can able to take one more request from the client, right? So means you're working with the job one, now I can able to take the job two. So once then I'll create, I'll find out the resources, I'll create a container for this job two, until you have to finish the job one. Then you can able to take the second job for the second container, right? So that is you are going to do with the resource manager and application master. So this is what we call it as a yard. So here we are avoiding the job tracker and task tracker, and instead of that one we are going to use a resource manager and node manager, so that the job tracker's responsibility is given to the resource manager, and the task tracker responsibility given to the node manager. Okay, clear?
Okay.
Clear now?
Yeah.
Right,
Yes.
right. So this is how the job is going to be processed. Now, okay, so we have a name node. Now, so if your name node goes down, right, so if your name node goes down, it's difficult for the resource manager to identify the reference in which data node, correct? So we cannot able to identify where the data is available. Suppose now every 60 minutes checkpoint occurs. Okay, what is a checkpoint means, the snapshot, right, whatever you wrote into the name nodes metadata will be written into secondary name node, right? That we call it as a snapshot. Okay, so whatever the data which is available in name node will be right, written into the secondary name node, right? See now I'll consider. So now 10:30. Okay, so the checkpoint occurs. When the checkpoint occurs, now we have a snapshot of the name node, and it will be updated into the secondary name node. Okay, so what is fs image file you're having in the which is a name node's metadata, the same is going to be updated into the secondary name node. Okay, now 10:30, now we have the updated data. Okay, in fs image file in the name node, and second name node fs image file. Are you getting any confusion here?
ఏం లేదు,
Okay.
సేమ్ ఉంటాయి దాంట్లో దీంట్లో.
అలా ఉండదు. ఫస్ట్ 10:30 10:25 వరకు ఇట్స్ డిఫరెంట్, రైట్? సో సపోజ్ రైట్ నౌ ద న్యూ fs image one is created. Okay, so
ఓకే.
now when the checkpoint occurs, this fs image one is going to be updated into the secondary name node. So now a secondary name node contains fs image one.
1.
Okay, now so what when next checkpoint time? 11:30,
11:30.
right? Till that, where the data is available now, so the data is written into edit logs.
సేమ్. ఓకే.
Okay, the data is written into the edit logs. So when the checkpoint occurs, now secondary name node will take the fs image one from the name node, and it will apply this edit logs from the name node, and then it will create a new fs image file. Okay, it will create
ఓకే.
a new fs image file, and this new fs image file, it sends back to the name node. So now the name node contains fs image 2. Okay,
ఓకే.
updated. Suppose, right? So then when is the next checkpoint time?
12:30.
12:30. So till that the data is written into edit logs,
ఎడిట్లో.
right? So the data till 11:30 we have updated into fs image file. So what about the data which is written 11:45, right? The data is written into edit
ఎడిట్
logs.
లాగ్స్.
Now if this particular name node goes down, okay, now if your name node is goes down, then whatever the data which is available in the edit logs are also going to be deleted, right?
ఎస్.
Now if you want to take the backup is available as fs image 2, right? Which is for the 11:30. Then what about the data which you write between 11:30 to 12:30? Are you going to lose the data or not?
ఎస్.
Yes, correct. So right, to overcome the situation, now whatever we are writing into the fs image file, this, right? So now this is how we are going to uh, work with the Hadoop after 2.0. Right, now you got clear. So in the Hadoop after 2.0, what are the masters? So name node, secondary name node, then HA node, right? So here in the before
ఎస్.
2.0 we don't have the HA node, so it's simply a secondary name node, right? In the Hadoop after 2.0 we'll have name node, secondary name node,
హెచ్ఏఎన్ఓ.
HA node. Okay, right. Now apart from that, we'll say we'll have a resource manager as a masters, and then coming to the slaves, we have data nodes, and right, task tracker node, it's a node managers we'll have. Okay, fine. So don't think that we always use yarn in the Hadoop after 2.0. This is your choice. Suppose if I want to use a MapReduce with a job tracker, we can able to use. Okay, right? In
ఓకే.
Hadoop after 2.0, if you want to run a job with a MapReduce, we can able to run a job. Means when you're running a job with a MapReduce, then you will get a job tracker, task tracker is going to process the job. Otherwise, if you want to run a job on the yard, then the resource manager and node manager are used to process the job. Now, so here in Hadoop 2.0 onwards, it will be the user's choice. Okay, so it will be
ఓకే.
the user size. Now you have to specify this one. Okay,
ఓకే.
fine, right? Any questions here? Okay,
నో, నో
right,
క్వశ్చన్స్.
right. So when we are talking about SDFS, so what is SDFS?
అడోబ్ డిస్ట్రిబ్యూటెడ్ ఫైల్ సిస్టమ్.
Right. Okay, it is a file system where we are going to store the data blocks physically, right? So we can have other definition. Hadoop is a combination of SDFS and MapReduce or YAR. Okay, so what is the rule? Whatever the data you are going to process first, that should be brought up to the SDFS. Once the data is available in SDFS, then only we can able to write the MapReduce or YAR. So whenever we are talking about SDFS, right? So again, we classify Hadoop daemons as two different ways. One is SDFS daemons, and other one is a map-reduce daemons. Okay. So what are the SDFS daemons now? SDFS daemons comes in the sense name node and secondary name node. Okay. Data node,
Okay.
right? So these are all the SDFS. So if somebody is saying that, so start SDFS means you have to start only name node, secondary name node, data node. In a cluster is SDFS running means what are the daemons running? Only the name node, secondary name node, data nodes. These are running. So in a cluster,
Okay.
map reduce running means job tracker as well as task tracker,
That.
and if you're configured with the resource manager, right, and the node manager, if these are running, then the map reduce or the yarn is running. That is, now you can able to run the job. So the cluster is running, the clustering is running in the sense both SDFS plus map reduce is running, or SDFS plus yarn is running. Okay, right? Suppose you have SDFS started, you have started the SDFS and you have not started the map reduce. Can you able to run a job?
No.
We can't able to run a job because the job processing can be done by the job tracker or the resource manager, but we have not started those daemons, right? So that is, the job is not going to be processed, but we can able to store the data because data nodes are up and run, name node is up and run, data nodes are alive, and secondary name node, so that we can able to write the data, but we cannot able to run a job if you're not started the map reduce or if you have not started the yarn. Okay, fine. So how we get the statistics about the name node, right? So what is how we get the information about the name node, secondary name node, data node, right? So we have a concept called web UI, right? What is a web UI? Web UI indicates
Yep.
web user interface where we can able to see the statistics or the information about the Hadoop daemons. That is, suppose if you open this one, name node is available on which port number? 50070,
70.
right? You have to remember this.
Always the same number or it will be changing?
Yeah, most of the times everybody will use this common representation for the web UI, right? So it
Okay.
won't change. Maybe if it changes, then we can able to see that in the configuration files, right? But 98 percentage everybody will use same kind of representation. Okay, 50070, 50075 for the data node. Okay, name
Okay.
node is available in 50075, and data nodes are available in 50075, and secondary name node is available on what is the port number? WebUI 50090. Okay, you have to
Okay.
remember this. Okay, job tracker
Okay.
is available on 50030.
Okay.
Okay, task tracker it's available on 50060.
Okay.
Okay, and then if you are using ER, right, 8088. Okay,
Okay.
and okay, fine. So now we'll see this, right? If you want to see the information of the name node, so what you have to write? You have to write the host name. How we write this? How to check that one? You have to write the host name, right? So colon 50070. So it's a first day in your office, right? You don't know, you have not remembered the host name. So how you can check the host name? Right now it's a first day in office, right? You don't know what is the host name. You need to wait. Did you wait until you'll get the documentations from your manager, or you'll start working with the environment, right? So we
Yeah.
have to know that one, right?
Until first we have to get the required information from the manager, right?
They'll give the manager, right? So we can get the it's like, suppose if you write slash etc, why should we wait until it will be right? We have to wait, but if you want to know that one, right, so just run the command cat space slash etc slash host names. So what is the host name? Right, 192 dot 168 dot 65 dot 131, which you entered here, right? So this is the
Yes.
host name, right? So how you know this? What is the host name? Because you are using Hortonworks, because you have seen here that, so that you told, right, it's 192. But
Yes.
so but if it's not specified this, right, you have not given this page, right? Because you are somewhere in the cluster, we don't get this, correct? So you will be
Yes.
given only the putty. So what you would write? Run the command cat space slash etc slash hosts, then it will display the host name, right? So here you can use this one, and the localhost dot local domain, because mine's a distributed mode installation, so here everything is configured as a local host. So this is the local host name. Okay, and
Okay.
if you write if config if c config, right, we'll get the address 190.168.65.131. So this is the IP address. Okay, or you can run other command host name. Okay, so what is the host name? Sandbox.huttonworks.com. You can use this host name too.
Okay.
Okay, now you got it. So what is the host name? So here, no, you
Yes.
have open now, take a terminal, write the host name, right? So host name is 192 dot, right, something 131 colon, now name node is available, and which web UI 50070, just write 50070.
Okay.
Okay, then we can able to see the information about the name node. Okay, so I'll teach you what all these things later. Now first we'll see, right, it's a name node page.
Okay.
Okay, so data nodes are available in 50075. Can we able to
7 5.
connect to the data nodes directly?
No.
Why?
We have to go through some resource manager like that.
No, we have to navigate to the data nodes through the name node. Generally, you'll have an option, browse the file system. So it's in Hadoop 2.7.0. It's a little bit different. Okay, so don't get confused here. Something is changed in this 2.7.0, right? So before the Hadoop, it's a little bit different, right? So here we are getting a
Yes.
different options in the Hadoop 2.7.0. So, but it's easy. Don't get confused. Okay, so if it is a before version, here you'll get an option, browse the file system, then you have to click on the browse the file system, then you will be navigated to the 50075. Okay, where the data nodes, where we can able to see the SDFS. Okay, like this one, browse the file system. So it's a 50075. Now you can able to see where, which, what is the directories and how the data files are available in SDFS. Okay, so what about the job tracker? Job tracker is available on 50030.
3 0.
Okay, 50030 is available? No, right?
No.
What is secondary name node? 500?
9
No, no.
0.
Secondary name node 90. Secondary name node is available. We can see here.
Yes.
If you open Numbary, you can able to see what are the running now. Okay,
Yes.
secondary name node is available. Name node, secondary name node is available, and the job tracker is not available. And then what is the task tracker? 50060 is available. Job tracker is not available.
Yes.
Then task tracker is not available, right? So we are using yarn, right? So yarn, what is the web UI for the yarn? 8000
9 0.
8080.
8 0 double. Yes. How
Okay,
can I put it to the channel? Host names.
once again. Okay, yarn is available on 8088. Okay,
Okay.
right, if you open 8088, now we have the yarn is available, where we can have the resource manager and node manager. So when you run a job, so we'll see that, right? I'll show you, I'll run a job and I'll show you the job status, right? Here the running is the host name. Okay, so this is
Okay.
8088 where we have the now yarn is running, not the map reduce. So right, map
Yes.
reduce is not running, so we cannot able to connect to the job tracker and we cannot able to connect to the task tracker. The same thing we can able to see from the Ambari page, right? See here we have available name nodes, right? Name node is live, correct? Right.
Yes.
Then which we are using resource manager is up and running, right? Node manager is up and running and we are using a yarn. So do we have the map reduce running now?
No.
Okay,
It just started. Yes.
right? So we don't have the map reduce. So if you want to run a job in the map reduce, then we have to specify a property that's map reduce dot framework dot local, right? Based up with the property, now we can able to run a job with a job tracker.
Okay. అది ఎక్కడ స్పెసిఫై చేయాలండి అది?
That we have to specify when the job running. Suppose if you're running a job in Hive, so there first we'll specify that property. We have to write. So write mapreduce dot framework dot local equal to classic. Otherwise, if you open sdfs hyphen site dot xm, sorry, mapred hyphen site dot xml, then you will get this property, right? So the property name is you'll have something like mapred dot framework dot local, right? We'll take three parameters. One is classic is a map reduce or yarn. Okay, that is you are going to use a job program. Will take the two properties. One is a classic and other one is a yarn. If you specify the classic, the job runs with a job tracker and task tracker. If it is yarn, the job runs with a resource manager and node manager. Okay, so what is the property? Mapred dot framework dot local is the property. Okay, Srikant, clear?
ఓకే. యా క్లియర్ అండి.
Fine. Okay, right. So now, how you check the cluster information? Now it's the first day in your office. Okay, so we have the different ways. Just write Hadoop space DFS admin, not Hadoop. It's a Hadoop 2.0, right? SDFS space DFS admin hyphen report. Okay, now we can able to see the. Let me change the font size. Okay, so it's saying that access denied. So I'm writing sudo hyphen u sdfs dfs admin hyphen report. Okay, now see, can able to see the information of the cluster. So the cluster host name, right? Cluster name, host name. So the cluster is available. How much you configure for the cluster? Okay, so how many nodes are available? Okay, got it? Right.
ఓకే.
So we have the different ways. So we'll see this in tomorrow morning session. We'll initially we'll have the two sessions on every day. Okay, so to make this faster, fine. So right, we'll see this separate topic. What are the different ways? How we check the information about the cluster, right? You know
ఓకే.
this. What is a DFS admin utility? Right. This we have to work. Right. This is main administration. Right. We'll see those things later. Okay. So we
ఓకే.
have to run this command where we can able to see the information about the Hadoop cluster. Okay. So
ఓకే.
right. So any do you have any questions, Srikant? Are clear with this?
యా. యా క్లియర్ అండి.
Okay. Fine.
మనం మీరు ఇందాక పోర్ట్ నెంబర్ చూపించారు కదండి, అది ఎక్కడ చూస్తాం మనం మామూలుగా?
Right, Andy. You have to open the browser. Okay, they are the web UI,
o-
means which we can able to access through only web, that is through browser.
okay.
Okay, so that's through browser, right? Write the host name and then colon, then the web UI.
అంటే వెబ్ యూఐ మనకి ఎట్లా తెలిసింది ఆ నెంబర్ ఎక్కడ ఉందని చెప్పి
This one, na?
500030 ఎట్లా అది
Okay, so if you go to the cd slash etc ls cd hadoop ls, we are using 2.3 ls. Okay, so what is the configuration file we have? So open the configuration file and see, right? Cat sdf-site.xml, right? If you open this, can able to see the data node is available where
ఓకే ఓకే యా
50075. Okay, so like this we can able to check that web UI. Suppose if it is a different, right, maybe everybody will use the same thing, right? If it is a different one, then open this configuration file. What is the location? Remember where I have checked, it is available under etc hadoop
ఈటీసీ కాన్
conf,
హడూప్ కాన్
right? So where all the hadoop configuration files are available.
ఓకే
Okay, we'll see sometime in a session we can see so what are these configuration files and what we'll find. Okay,
ఓకే
yeah, okay then, right? So any other questions, Shrikant?
యా ఏం లేవండి
Right, so we'll see in next session. I'm going to teach you how to Hadoop configuration files. Okay, and we'll see one more topic, how to check the Hadoop cluster information, right? So I'm going to teach you these two topics next. Okay,
ఓకే
so right, do you have Hadoop configured in your machine? So now
ఎస్
I'll make you the work, right? So not all the time theory, because I think you don't need this theory, correct? So you need to have hands on. Okay, so but the thing is, but basically you need to know the architecture.